Hello students, how are you? Doing well? Very good. Dear students, we have been learning very important organic chemistry chapters. In previous lecture, we have completed alcohols, phenols and ethers. Today, we are going to learn very important organic chemistry chapters is aldehydes, ketones and carboxylic acids. That means carbonyl compounds. These are the compounds which plays a major role with respect to name reactions, oxidations, reductions, CC bond formation, CC double bond formation and various metal catalyzed reactions. So this category of compounds plays a very big role in organic chemistry. However, we will learn in detail about their preparation, structural elucidation, their nomenclature and various methods available for the preparation of aldehydes and ketones, and we are going to learn chemical reactions which undergoes these compounds aldehydes and ketones. Please subscribe my channel Venus Academy if you are not yet subscribed, and don't forget to click on like button and bell button. Let us see the topic aldehydes, ketones and carboxylic acids. These are the compounds having carbon attached to oxygen with double bond, and if the R is hydrogen, these are aldehydes. If R is alkyl or aryl, two sides, then these are ketones. So what is the structure? This is the carbon having double bond with oxygen and two carbons or hydrogens with CC single bond. Overall hybridization of carbon in carbonyl compounds is sp2 hybridization. What is the shape of sp2 hybridization? It is trigonal coplanar. Since it is planar, the bond angle between these two substituents or between this and this is about 120 degrees. So it is sp2 hybridized molecule where carbon is having double bond with oxygen, and remaining substituents, if R equal to hydrogen, then they are known as aldehydes, and R if it is alkyl or aryl groups, then two sides if it is aryl or alkyl groups, then it is known as ketones. Yes students, the bond angle is 120 degrees and 120 degrees. What else? These compounds are highly polar because the oxygen is electronegative atom which pulls this electron density towards it to attain partial negative charge, and this carbon attains partial positive charge, and the bond between carbon and oxygen is a pi bond where oxygen will use its p orbital to form pi bond, side on overlapping pi bond. So overall carbonyl compound is going to have 3 sigma bonds and 1 pi bond. The hybridization is sp2 hybridization. This is the structural elucidation of carbonyl compounds. Then what are the common carbonyl compounds we come across? For example, if it is a hydrogen, and R can be alkyl or aryl. It doesn't matter. These are aldehydes. If R equal to alkyl or aryl and this side alkyl or aryl group, then these are known as ketones. And one more important category of compounds under this category is carboxylic acid. If this hydrogen or R group in place of this, if it is substituted with hydroxy group, then these are known as carboxylic acids. These are the three category of compounds where carbon is having double bond O. Yes, students? So further it can have acyl chlorides or acyl halides. It can have esters. It can have amides. It can have anhydrides. These are all comes under the category of acids, whereas aldehydes and ketones, for example, this is acetaldehyde. And its common name is acetaldehyde. When it comes to IUPAC nomenclature, it is named as ethanal. So in place of alkane, where you will write ethane, this is ethane, you have to add Al. Al stands for aldehyde. For example, here this is 2-propanone is an IUPAC nomenclature, and the common name of this compound is acetone. So these are all aldehydes, these are ketones. So the common aldehydes or ketones we come across are here. The starting one carbon containing aldehyde is formaldehyde. This IUPAC nomenclature is methanal, Al, methanal. And 2 carbon containing aldehyde is acetaldehyde. Then comes propionaldehyde, and very important compounds under this series is aromatic aldehydes. This is benzaldehyde, and when benzaldehyde is substituted with hydroxy and methoxy groups, it is known as vanillin. What we use in ice creams, vanillin. So it is isolated from vanilla seeds. When it comes to cinnamaldehyde, this cinnamaldehyde is isolated from cinnamon. And very important another compound is salicylaldehyde. Yes, students? So cinnamaldehyde, this is salicylaldehyde. when it comes to ketones, this is acetone and it can have benzene ring one side, and this is acetophenone. Though each compound is having IUPAC nomenclature, but commonly these ketones are known with their common names. Acetophenone, propiophenone, and if two sides, this methyl is also substituted with benzene ring, then it is known as benzophenone. So these are all, you can write n number of compounds with different structures. It doesn't matter whether this group, it can be alkyl or aryl, and it can be alkyl and aryl. Whereas this aldehydes, this alkyl or aryl or heteroaryl. For example, this is furaldehyde or for fural. So it can have heterocyclic aldehyde or alkyl aldehydes or aryl aldehydes. So the common factor or the common structure which is we come across is RCOH. Is this is commonly written as R. Aldehydes are commonly written as RCHO. Ketones, yes, this way you can write. So these are the compounds having carbon with attached to alkyl or aryl groups. Let us see their preparation. Yes. So let us see the common methods for the preparation of aldehydes and ketones. So what are the general methods available for the preparation of aldehydes or ketones? We have already come across the oxidation of alcohols. We will get aldehydes and ketones. Let us see. If I take primary alcohol, let us take acetaldehyde, and upon oxidation, so the common oxidizing agent is chromium trioxide, and I have explained during alcohol's oxidation. So we can use chromium trioxide in sulfuric acid. It is Jones reagent. If I use chromium trioxide, sulfuric acid in dichloromethane, it is Collins reagent. Then another important category of compound is pyridinium chlorochromate. Pyridine with HCl plus chromium trioxide. It is known as PCC. Pyridinium chlorochromate. So this is almost neutral reagent, and this reagent name is Sarret reagent. So PCC reagent or whatever reagent you want to use, you can use to oxidize primary alcohols to. These alcohols are going to give this oxidation, that is acetaldehyde. In place of primary alcohol, if I take secondary alcohol, for example isopropyl alcohol and PCC I am going to use, it is going to give ketone. This is common name is acetone. So like this oxidation of alcohols we can get carbonyl compounds. The whatever the alcohol we take, you are going to get, if it is primary alcohol, you are going to get aldehydes. Secondary alcohols, you are going to get ketone. If at all, if you use tertiary alcohols, so these compounds do not undergo simple oxidation to aldehydes or ketones. If at all, if you use KMnO4 like strong oxidizing agents, they undergo carboxylic acids with different number of carbons. So simple oxidation tertiary alcohols do not undergo, whereas primary alcohols gives aldehydes, secondary alcohols gives ketones. Dear students, it is very simple. Just remove hydrogen from here and here, and in this case, so minus water, so minus hydrogen, you are going to get aldehydes or ketones. Primary alcohols, when I pass through, these are vapors of, since high temperature, it is going to be in vapor state, 300 degrees centigrades. Copper tube, red hot copper tube, when I pass vapors of alcohol, I am going to get aldehydes, primary alcohols. I am going to get aldehydes. If I use secondary alcohols, let us take same isopropanol like compound, and when I pass through copper, it is going to give ketone. Next students, so these are common methods. Next, another method which is known for the preparation of aldehydes or ketones is ozonolysis. So what is ozonolysis? Let us take one example and see. If I take propene and when I do ozonolysis, when I pass ozone, it is going to break here. The simple way is add oxygen to this side. I made a separate video on this ozonolysis. If you want detailed mechanism with lot of examples, please go through that video. I am going to give the link below of this video. Yes, so for our understanding, it is for the preparation of aldehydes and ketones. Whatever the compound you get with double bond, just break the double bond and add oxygen towards two sides. Yes, so however, it is going to give ozonide like hut like shape. So just ozonide structure is, it is like hut. Yes, so ozonide and this, when we treat it with zinc and water, it is going to give carbonyl compound. This is acetaldehyde when I take propene, and this side it is formaldehyde. What is the common name of this formaldehyde? Methanol. Yes, students, you can post your questions, right? Surendra Mishra, what's your doubt? Okay, methanol, and this is ethanol. Yes, Mishra, you can write again if you have doubt. Yes, so this is ozonide. Next, when I take this 2-propene Methyl 2-propene, 2-methyl propene. This is 2-methyl propene. So how to write? So I can write CH2 here, CH3. Yes, if you want you can write. And simply break here. And when you add ozone, you can write the structure like this: CH and O, CH2. This is ozonide, and when we treat this ozonide with zinc and water, it is going to break to give acetone, and this side what we are going to get? This is methanol, that is formaldehyde. Dear students, whatever the compound, it has been asked in all entrance exams, especially JEE Mains and NEET. Every time you are going to get one question. So simply they will take this cyclohexene and they may put here double bond or here double bond, whatever wherever they want they can put double bond, and they will ask the compounds. Yes, so it has been asked every time in JEE Mains and NEET. Even in 2020 also we had you got this question from ozonolysis. So please go through complete detailed mechanism of ozonolysis what we learnt during previous class, that is hydrocarbons lesson. Yes students, so methyl propene gives this. So whatever the double bond, let me check this. So if I have double bond here, what I am going to get? Just break here, I am going to get dialdehyde. So here double bond, here double bond O. So this is the way you can add oxygen to these alkenes. Next, so very important methods for the preparation of aldehydes and ketones is hydration of alkynes. Yes students, by hydration of alkynes. So alkynes, what we are going to get are Markovnikov's products. So what we are going to get, for example, if I take, what is this compound? Ethyne or acetylene. This acetylene, when I treat it with water in presence of sulfuric acid, that is acid and mercuric sulfate. So this co-catalyst, it is going to act as co-catalyst. So sulfuric acid, it is going to give H plus ions. These H plus ions are going to be taken up by, added to this to give carbocation intermediate. Now this OH, what is there in water, is going to add to this to give what is this compound? Is it going to exist? Vinyl alcohol. Vinyl alcohol is nothing but tautomer of acetaldehyde. How? It is going to shift here to give this single bond and hydrogens, two hydrogens are there, and this hydrogen is coming here. So tautomer of acetaldehyde. Acetaldehyde can be prepared starting from acetylene by hydration. So this is the only compound where we are going to get aldehyde. So higher than this, we are going to get ketones. For example, if I take 2-propyne propyne CH3 CH. So here what I said, Markovnikov's addition is going to take place. Here H, OH minus. So the first step, what we are using, sulfuric acid and mercuric sulfate, it is going to have H plus ions. So the whatever H plus ions there in the reaction mixture will be added to this to give, there is a chance of getting two carbocations. This is one carbocation. So newly added hydrogen is here. This is secondary carbocation, and it also can form, there is a chance to form this carbocation, right, where this hydrogen is coming onto this carbon and this is primary carbocation. So among these two carbocations, which is more stable, this secondary carbocation is going to be more stable, so it is formed major, and it is going to undergo to take nucleophile, that is OH, which is there in the reaction mixture, will be added to this carbon to give and double bond CH, and already one hydrogen is there. So this is, what is this? Enol. The common name of this type of compounds are enol, and these enols are nothing but tautomers of ketones. CH3 double bond O, CH, and already this hydrogen is here, and this hydrogen is coming onto this. So now it is acetone. Acetone is a ketone. So this is how the common methods for the preparation of aldehydes and ketones can be followed, starting from alcohols by oxidation or alcohols passing through copper at high temperatures or ozonolysis, and from alkynes. So these are general methods for the preparation of aldehydes and ketones. Let us see specific reactions where you can prepare aldehydes, exclusively aldehydes, and exclusively ketones, where these reactions gives exclusive specific compounds. Let us see one by one. Yes, students. So, dear students, let us see the preparation of specific aldehydes. At the beginning, what I said, the aldehydes and ketones are the important compounds where we come across a number of name reactions for the preparation as well as their chemical reactions. Dear friends, dear students, if you are not yet subscribed to my channel, please subscribe my channel Venus Academy if you are not yet subscribed, and don't forget to click on like button and bell button. Dear students, let us see the preparation of aldehydes by Rosenmund reduction. Rosenmund reduction. So it is very simple, students. The name is Rose and Mund. So Rose and Mund reduction. What it is? Acyl halides, for example, benzyl chloride. This is benzyl chloride. When I treat it with hydrogen in presence of palladium carbon, so it is going to reduce halogen to hydrogen, and this carbonyl compound is going to be stable when only the condition is I have to add barium sulfate. So in this barium sulfate, the sulfur which is there as sulfate, this sulfur is going to act as poison for the activity of palladium, where barium, this sulfur behaves as a poison towards this palladium, and it stops at aldehyde stage only. This is aldehyde, where this chlorine is reduced to hydrogen. If I do not add this barium sulfate, very important, students, if I do not add barium sulfate, it is going to undergo further reduction to alcohol. Yes, so Rosenmund reduction is use of barium sulfate. Yes, so similar reaction will come across during alkynes. So alkynes to alkene can be done by palladium carbon by the addition of, yes, so barium sulfate. So sulfur is a poison where it stops at aldehyde stage. In Lindlar's catalyst, yes, it stops at alkene stage. So Rosenmund reduction, one method. So specifically we are going to get aldehydes, and the second method is from nitriles. Let us take nitrile, and when I treat it with stannous chloride, tin dichloride, stannous chloride in presence of HCl, I am going to get RCH double bond. Is upon hydrolysis, it is going to give aldehydes. Yes, so it is very specific reagent where stannous chloride is going to reduce only nitriles. In this case, double bonds are intact. Let us take double bond containing compound. This double bond, if I do using hydrogen palladium, this is going to be reduced to alkane, RC. This double bond is going to reduce to single bond. However, if I use this SnCl2 in presence of HCl, I am going to get exclusively aldehyde. This double bond is going to be intact, where nitrile is going to be reduced to aldehyde. So nitriles, we can do preparation of aldehydes. And very important reagent which has been asked in all sessions is diabol, diisobutyl aluminium hydride, a reagent which is specific for the reduction of nitriles. Diisobutyl aluminium hydride, it can be written as diisobutyl aluminium hydride, or you can get it as like this. The representation is important, students, because you may get in exam in any form, or you can write it as diabol H, or you can get it as diabol H, no space. So what is this reagent? It is very important reagent where this aluminium is having hydride, which is negatively charged hydride. Yes, it is a metal, is going to have positive charge. This hydride is going to have negative charge, and isobutyl 1 2 3 isobutyl. You can have the structure like this also. In some exams you may get like this structure also. So this is the overall reagent diabol H, and it is very pyrophoric, means it burns in air. Pyrophoric, and its handling is very important. Dear students, I made a video how to handle these reagents. Please go through that if you have any doubts, because its handling and their quenching, means how to destroy after use, it's very important, and you are going to use this kind of reagents at higher classes or during your research only. So diabol H is a reagent. Yes, so pyrophoric, aluminium hydride is a pyrophoric reagent, so its handling must be done under very specific conditions. Anyhow, regarding our chemistry, so this diisobutyl aluminium hydride specifically reduces nitriles to aldehydes. So this only one hydride is going to be given. So this nitrile, when I add diisobutyl aluminium hydride, it is going to give aldehydes. This is one of the methods for the preparation of aldehydes from nitriles. And not only this, and another one more category of compounds diol H is going to reduce. What is this? What is that? It is ester. Ester to aldehyde. So in carboxylic acids I am going to explain in detail. For example, if I take long chain acid ester CH2 taken 9 times, and this is ethyl ester, and when I treat it with diisobutyl hydride, I can write diol H. Diol H. It is going to give aldehyde. This is very important concept, students. You have been asked in 2019 JE mains number of times. In all sessions you got diol H based questions. Yes, so it is stopped at aldehyde stage only. However, in place of diol H, if I use LaH, lithium aluminum hydride, it is going to reduce this aldehyde also to alcohol. So LaH is not going to be used. Diol H has to be used. So diol H is very specific reagent where nitriles, this is cyanide, I can say cyanide or nitrile, and esters. Please remember or write down somewhere. Diol H is going to give aldehydes, and esters also aldehydes. However, during really speaking, when you are doing synthetic chemistry and you have to do very fast reactions and you have to do very fast workup under anhydrous conditions, otherwise it is going to reduce further. So simply as soon as add your diol H and do the workup. Anyhow, that is practical problem. So when it comes to preparation of aldehydes, you can prepare from nitriles and esters. So preparation of aldehydes, let me take specific example, benzaldehyde. There are 4 types of reactions available for the preparation of benzaldehyde from toluene. Let me take one by one. When I take toluene, this is toluene, students, and treat it with chromyl chloride, CrO2Cl2, chromyl chloride. This name reaction is Etard reaction. Most of the times you will get questions based on name reaction. So Etard is the name of a scientist. In previous, just now what I said, Rosenmund is a scientist name, and stannous chloride reaction is a Stephen reaction, student. Just now I forgot to mention Stephen reduction or reaction, right? So when it comes to this benzaldehyde preparation, Etard reaction, chromyl chloride, it is going to form chromyl complex. This is chromyl complex, chromine complex. When I do further hydrolysis using acid hydrolysis, it is going to break here to give chromic acid and the benzaldehyde. And this benzaldehyde preparation, these 4 methods are very specific and important, and which are has to be remembered throughout your life, because these questions you may get during your interview also. So if you are already completed your PGR degree and you are going to work as a chemist, and these questions are sure, I am sure you are going to get these questions, right? Anyhow, so this is one method, and the second method is Oxidation using chromium trioxide and acetic anhydride. Toluene, chromium trioxide in presence of acetic anhydride. What is acetic anhydride? CH3COO. I can write like this also. Acetic anhydride, right? So acetic anhydride in presence of chromium trioxide, it is going to oxidize toluene to benzaldehyde. And the intermediate is, you may be asked this intermediate also. OCOCH3 and OCOCH3. Yes, so this intermediate is going to hydrolyze upon acid hydrolysis to give benzaldehyde. This is second method. And the third and important commercial method for the preparation of benzaldehyde is from toluene by halogenation followed by hydrolysis. Toluene, when I do halogenation, free radical halogenation, this is alkane. How to do halogenation? Use chlorine gas in presence of light, that is HNu. HNu is a light. Yes, students. So light, you are going to get dichlorobenzol. So two chlorines are going to be added. This upon hydrolysis at 100 degrees centigrade, these two chlorines are going to be hydrolyzed to take up water and to give benzaldehyde. This is very important method and commercial method. Yes, student. So it is a commercial method for the preparation of benzaldehyde. Next. Yes, students. Gutterman. Koch formylation. What is this reaction? Take benzene and treat it with carbon monoxide in presence of dry HCl. So it takes up carbon monoxide in presence of anhydrous aluminum chloride, or I can use cuprous chloride, CuCl. Yes, so this takes up aldehyde carbon monoxide to give benzaldehyde. Yes, students, I have made video on detailed mechanism of this Gutterman-Koch formulation. You can go through that. That link I am going to give below of this video. So ketones can be prepared starting from Grignard reagent, for example RMgX. And when I treat it with cadmium chloride, transmetallation. The concept is transmetallation. Please write down transmetallation. At lower classes it may not have that importance. Metallation. So what is happening? So here cadmium, this is magnesium. It is going to exchange with cadmium. It is going to take up alkyl groups, two alkyl groups here, R2 plus magnesium. X is already here, 2X is here, and 2 chlorines. That means X and chlorine 2. Right? It is balanced. This cadmium, alkyl cadmium compound, when I treat it with acyl halides, for example, 2 moles of acyl halides, and this acyl halide is going to react with cadmium alkyl group. Yes, students, what is the charge on this? Yes, usually it is negatively charged. This is also negatively charged, this is positive. Now, this chlorine which is there on this acid group or acyl group, it is going to take up this. Yes, since we are using 2 moles here, let me write 1 R CO, this chlorine going out, and it is going to be taken up by cadmium. Yes, so let me take one more here, 2R OCl. It is going to take up this and it is going out to give 2 moles of ketone. Yes, I can write here R prime CO, and this is the R which is coming from here. Yes, students, so both are same. So this is how cadmium chloride. So transmetallation can be done to get this acid from acid chloride to ketones. Ketones can be prepared via cadmium chloride. Then very important method is from nitriles, Grignard reaction of nitriles. This is one method, and second method is nitriles via Grignard reaction. When I take nitrile CH3 CH2 CN and treat it with alkyl phenyl, let me take phenyl magnesium bromide. Yes, so this is Grignard reagent in ether. Usually where do you do? Diethyl ether. Let me take ether as a solvent. So this phenyl group is going to add to this carbon, and we are going to get imine as an intermediate CH3 CH2 CN, and this is magnesium bromide, and remaining is benzene ring. This upon hydrolysis, it is going to give ketone. Can I write like this? C double bond O, and this is CH3 CH2. What is this compound? Common name of this propiophenone. Yes, so this is another method of preparation of ketones, and very important methods for the preparation of ketones is Friedel-Crafts acylation. So benzene, let me take benzene. When I treat it with CH3CO acetyl chloride in anhydrous aluminum chloride in a solvent, carbon disulfide is a solvent where its boiling point is around 50 degrees centigrade. I am going to get acetophenone. So can anyone write the mechanism? It is very simple. The first step involves generation of carbocation plus aluminum chloride. It is going to generate acyl carbocation CH3. This is carbocation or electrophile. Generation of electrophile Aluminium chloride minus. The second step is formation of sigma complex. What is going to happen? Benzene which is there is going to take up this to give sigma complex. So this in third step it is going to lose hydrogen, removal of hydrogen. So this is common to all aromatic electrophilic substitution reactions, these steps. So removal of hydrogen, you are going to get acetophenone. This is how you can prepare ketones. Dear students, you can prepare aldehydes and ketones following these are the methods which are commonly used and versatile methods where there are specific examples and modern chemistry also is there, but at this stage these are enough to learn. Yes students, do you have any queries or doubts in these chapters or in these topics? Please write down. Physical properties of aldehydes and ketones. Yes students, for example, if I take formaldehyde, it is a gas. If I take acetaldehyde, it is volatile liquid, means low boiling point liquid. And the first ketone, when I substitute this with methyl group, what is this? It is acetone, and its boiling point is 56 degrees centigrades. Dear students, it is going to be liquid. Formaldehyde is a gas, acetaldehyde is a volatile liquid, and it is a liquid. Acetone is a liquid. And the more homologs you move forward, it is going to be liquids or higher solids, or higher homologs are going to be solids. Yes students, so the key points what you have to focus is aldehydes or ketones, boiling points are higher than hydrocarbons, and ethers. Yes students, so boiling points of aldehydes and ketones higher than these hydrocarbons and ethers. What are the hydrocarbons we have learned? For example, alkane, alkene, alkyne and benzenes. Yes, so similar, if you take acetone, for example acetone, so 3 carbon containing compound, and ethyl, methyl, ether, if I take this similar compound methoxymethane, and the boiling point of acetone is higher than the ethers, however lower than alcohols. Why alcohols are going to be high boiling solvents? Because alcohols are having hydrogen bonding, whereas these aldehydes and ketones are not going to be have hydrogen bonding. Intramolecular or intermolecular hydrogen bonding is not possible in ketones or aldehydes, right? So alcohols are high boiling, whereas hydrocarbons and ethers are going to be less boiling point containing than these aldehydes and ketones. And when it comes to solubility, Yes, students, any guess? So when it comes to solubility, formaldehyde, acetaldehyde, acetone, water soluble. So lower compounds water soluble, 100% water soluble, means miscible with water. When this chain goes on increases, so sparingly soluble or immiscible. Yes, students. So that is how. So the solubility depends on the molecular weight. So the lower molecular weight containing compounds are soluble in water because these compounds will form hydrogen bonding with water. If it is water, so it is going to form water hydrogen bonding with water. So that is why acetone is soluble with water and acetone is used as solvent for the washing also in organic synthetic laboratory. Yes, students. So this is how physical properties, nothing much to worry. Usually you will be tested on the boiling points based on these hydrocarbon ethers, and one more key point is, so straight chain compounds, straight chain, suppose it is straight chain compounds will have high boiling points, high boiling points compared to branched chain. Branched chain compounds will have low boiling point. So these are physical properties of aldehydes and ketones. Thank you, students. Thank you for watching this video. Please subscribe my channel Venus Academy if you are not yet subscribed, and don't forget to click on like button and bell button. We will meet again with carboxylic acids. Till then, bye, sayonara, all the best, arigato gozaimasu. Bye, students.